So here we're going to talk about limits involving infinity, okay? So first definition, 1.6.1 and 2, limits of infinity. So if I take the limit as x approaches c from the left of f of x, and we get infinity, what this means is as I'm coming in from the left, I'm going up to infinity on one side. So in the past, before now, we just said that this limit did not exist. Now we're saying that this limit actually equals infinity. Okay, so that's a left-handed limit that's equal to infinity. Let's do the right-handed limit. I see the plus, I see a right-handed limit. And so as x approaches c from the right of f of x, we're saying that that equals infinity. That means we're coming up to infinity on the right side. Okay? Doesn't matter if there's not anything on the left side here. This is a right-handed limit. However, if I see that I have a limit as x approaches c of f of x and it equals infinity, what that means now, if this limit here, the left and the right-hand side have to agree, correct? So the limit of f of x as x approaches c is infinity. That's how we read it. This is what that graph would look like. Not only is the right-hand limit going to infinity, but the left-hand limit is going to infinity. And since both are heading towards infinity, this limit does not exist, but rather is equal to infinity. Okay? So kind of reformulating our ideas here, no longer just because we have a vertical asymptote, we say the limit doesn't exist anymore. Now we are defining the limit at infinity. We had to make this distinction because technically infinity is not a real number. Okay? Now, another definition here. Definition is 1.6.3. and it's for a vertical asymptote. So how do I define a vertical asymptote? I'm going to base it off of kind of what I've done here, and I'm going to let I be an interval that either contains C or has C as an endpoint. And so here it is. If the left-handed limit equals plus or minus infinity, or the right-handed limit equals plus or minus infinity. Okay, so a vertical asymptote occurs if one or both of these two things are true. Or means that it could be one or the other, or it could be both, okay? So if I say, I'm going to take you to the movies or take you out to eat, that means when Friday night rolls around and be like, okay, we're going out to eat, but I've decided not to go to the movies, therefore I didn't lie to you, right? And opposite of that, say, instead we're going out to eat, but we're not going to the movies, then I still didn't lie to you. But say I'm going to be this cool dude, and I say, all right, we're doing movies and we're going out to eat, right? And so I still didn't lie to you because I said or there, okay? So or means either this one is true or that one is true or both are true, okay? So it could be both, doesn't have to be. All right, if that is true, then what? X equal to C is a vertical asymptote of the function. So if I want to show that there's a vertical asymptote there, I need to take left or right-handed limits, and if my left or right-handed limits are plus or minus infinity, then that tells me right there that I'm dealing with a vertical asymptote here, okay? So let's try to find and evaluate these limits, these infinite limits, and then if there are any vertical asymptotes, figure out what they are. Okay, so the first one here, the limit as x goes to 2 from the left, okay, of x plus 2 over 2 minus x. Now, how are we going to do this? Well, literally what I'm thinking about when I see 2 on the left, I'm thinking about a number like 1.999, something like that. That's kind of what I'm thinking, a number slightly smaller than 2, okay? So if you want, you can plug that number in, all right? So I literally plugged in 2 to the left, okay? So how do I do this? I think about this kind of in the way of this 1.999 scenario going on, correct? Now, when I subtract this in a calculator, right? If I do the denominator here, 2 minus this thing right there, that's a really small positive number. That really small positive number is 0.0001. And then this number here, I mean, you could say 4, it's okay. If you wanted to use the same number here, it'd be like 3.999, which you guys see, those are really close to each other, okay? So I'm okay with whatever you want to do. But you notice here, I don't have an equal sign, I have an approximation. Because technically, I could get as close as I wanted to the left of 2, and I still never get there. So you got to be careful. It's not equal to. I'm just doing a little bit of hand waving here. Now, if I multiply this division out, okay, I'm going to get 4,000, which that's telling me that's getting really big. The closer I get to 2 on the left side, the bigger my number becomes, okay, because that means this denominator is getting really, really small, and the smaller the denominator, the bigger the quotient becomes, okay? So I'm going to say this is plus infinity. Whenever I take my limit as x goes to 2 from the left, it's positive infinity. So what does that tell me? That tells me that I have a vertical asymptote. It tells me that my vertical asymptote is at x equal to 2. How do I know that? Because I'm taking the limit as x approaches 2, even though it's from the left. I'm seeing, you see right here, I'm going to 2 from the left. I'm going up to positive infinity. There's a vertical asymptote at x equal to 2, okay, for that function there. Now, let's do the limit as x approaches 2 from the right. So the only thing that's different now is I plug in 2 from the right here and here. Well, the other thing that's kind of a big deal is now instead of subtracting a smaller number, I'm subtracting a bigger number. So instead of having a positive in the denominator, all of a sudden I'm going to have a negative in my denominator, okay? And the 2 up top, it still stays the same. We're just adding there. And so what do I get? I get like negative 4,000, and what does that tell me? I'm heading to negative infinity, okay? And since I'm going to negative infinity, as I take a limit to the right, if my limit to the right is negative infinity, what does that tell me? X equals 2, right? My c here was to the right of positive 2. And so this is x equal to positive 2, if I follow my formula, is a vertical asymptote, okay? Now, this one right here, this limit, if I take this limit, what do I know? Well, the only difference here is it's the limit as x goes to 2, okay? So not only do I have to consider the left, I also have to consider the right. Why does it not exist? Okay, why does this limit not exist? Well, because the left-hand limit equals positive infinity, the right-hand limit equals negative infinity. Therefore, these limits do not work out for us, okay? So since they are not equal, what does that tell me? That tells me that the limit does not exist, okay? Now, just because the limit does not exist doesn't mean that there's not a vertical asymptote or there is a vertical asymptote. But finding vertical asymptotes, by our definition, we're looking at left-hand limits and right-hand limits. So if one or both of those are infinite, then we know we have a vertical asymptote. Okay, so just wanted to illustrate that to you, what's going on there. All right, guys, hopefully this video was helpful to you.